Good day and welcome to today's class. Today's class is a continuation of our previous classes on SS1 mathematics. At the last class, I gave us the mathematics curriculum for SS1. We looked at the various themes and the topics under each theme. And I promised making a video for each of the topics. And today we shall begin with the number-based system, which is under the theme numbers and numeration. Under the topic number-based system, we shall look at the following subheadings: conversion from one base to base 10. We'll also look at how to convert decimal fractions in one base to base 10. We'll then look at the conversion of numbers from one base to another base other than base 10. Next, we'll look at the addition, subtraction, multiplication, and division of number bases, which are the mathematical operations. Then we'll end the class with application of computer programming. We are going to take it step by step. Maybe we'll take each of the subheadings one at a time in every lecture. At the end of the topic, students should be able to, 1, be able to convert numbers from other bases to base 10. We should also be able to convert decimal fraction from other bases to base 10. At the end of the class, you should be able to know how to convert from one base to another base and also perform basic operations on number bases with the exception of base 2. At the end of the class, we should be able to apply number-based systems to computer programming. So these are the objectives of this topic. Now let's pick the first subtheme, which is conversion of numbers in base 10 to other bases. A number-based operation is an operation carried out in numerals other than base 10, which is the decimal system. The base 10 is referred to as the decimal system. And the different bases have specific digits. For example, we have the base 2. In the base 2 system, we have digits of zeros and ones. These are the only 2 digits you will find in the base 2 system repeatedly. Also in our base 3 system, we have digits such as zeros, ones, and twos, because if you group in terms of threes, you won't have any other digits other than zeros, 1, and 2s. For the base 4 system, we have digits. You'll find digits of zeros, 1s, 2s, and 3s. No other digits you will see other than this. The base 2 system, we refer to it as the binary system. I doubt if there's a particular name for base 3 and base 4. Also, base 5, for the base 5 system grouping in 5, you therefore know that you should be expecting to see numbers like digits like zeros, 1s, 2s, 3s, and 4s in the base 5 system. Also, we have base 6, base 8. Let me just give you those that are of importance to us. You have base 6, base 7, you know the digits you are to get from them. Base 8, you have zeros, 1, 2, 3s, 4, 5, 6, and 7. These are the digits you will find under the base 8 system. If you are to determine if a figure is under base 8, then you must only find digits within this range. And the base 8 system is said to be the octal system. We have the base 9, and the base 10 is that which we already know of, which is the normal counting system of we humans. So this is just an illustration or an idea, which is like a revision to what you have done in your junior secondary. We are to convert each of these numbers given in base 10 system to either base 3, base 5, base 6, and base 8. So I shall be expressing each of these numbers in base 3, base 5, base 6, and base 8. Now, 8, which is given as number of balls in base 10, we are to express it in base 3. Now, what this means is, if you have 8 balls, group them in terms of 3s. Okay, so this is what I'm going to do. If I have 8 balls, this will be 1, 2, 3, 4, 5, 6, 7, 8. Now, if I'm to group them in terms of 3s, this will become 1, 2, and this is not up to 3. So what this means is that I have 2 groups of 3s and 1 group of 2. So expressing this in base 3, it therefore means that I have 2 groups of 3s and 2 remainder. So therefore 8 in base 3 is said to be 2 to base 3. What about 12? 12 in base 3, we're asked to write it in terms of base 3. So divide 12 balls into 3. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, it therefore means that we have 4 sets of 3s, remainder 0. So when you group 3 in terms of 3s, you are going to have it in this form. That is 1, 2, 3, 4. But 4 is not a digit in base 3. So we have 4 groups of 3s, of which can also be divided by 3 again. So we have 1 group of 3s with 1 group of 3s and 0 remainder. 12 in base 3 can be said to be 1, 1, 0 base 3. Remember, in base 10 system, when you have 999 and 1 is added to it, you have 1,000, of which the place value of this is units, while that of this 0 is tens, hundreds, and then thousands. Same thing we have with base 3. In base 3, when you get the first place value of 3 is 3 raised to the power of 0, which is 1. The next is 3 raised to the power of 1, 3 raised to the power of 2, and 3 raised to the power of 3 in that order. So you can't have more than 3 sets in a particular place values, just like we have in the base 10 system, where you can't have more than a group of 10. So also in base 3, you can't have more than a group of 3. So when we have a group of 4, we need to take them to the next higher value, which is 1 set of group of 3s plus 1 group of 3s, that is this, 1 set of 3s plus 1 group of 3s plus 0 remainder. 15 can be written as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, we have they are all in groups of 3s. So we have a group of 3, which is 1. We now have another 2 groups of 3s and 0 remainder, all in base 3. 20 can be written as, let's group them in terms of 3s too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in terms of 3s, they are all grouped in 3s. Only 1 is in 2s. So we have, in terms of 3s, we have 1. We also have another set, which is 2. So we now have 2 groups of 3s, 0 groups of 3s, and 2 remainder, which is said to be in base 3. So this is how you can express numbers, convert numbers from base 10 to base 3 using the tally system. Let's also work for base 5. In base 5, when you have to convert 8 in base 5, also 1, 2, 3, 4, 5, 6, 7, 8. It therefore means we have a group of 5, remainder 3, all in base 5. 12 in base 5. This gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have two groups of 5 and remainder 2. So we have two groups of 5, remainder 2, all in base 5. Also, 15 in base 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is said to be three groups of 5 and 0 remainder, all in base 5. 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have it as 4. So we have 4 groups of 5, remainder 0, all in base 5. Or you can just simply say 20 divided by 5 is said to be 4, remainder 0 in base 5. Same thing we did when we were looking at base 3. 20 divided by 3 is said to be 6, remainder 2. But this is the remainder 2. But 6 is not a digit in base 3. So we have to divide that 6 again by 3. And we got 2, remainder 0. So that is how it is gotten. So, but we are still using the tally system. To convert to base 6, 8 in base 6, we now have 1, 2, 3, 4, 5, 6, remainder 1, 2. So we have one group of 6, remainder 2. 8 in base 6 is said to be 12 in base 6, or 1 to base 6. 12 to convert to base 6, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have it as two groups of 6, remainder 0, all in base 6. Remember, the base is written as a subscript. 15 in base 6 can be said to be 1, 2, 3, 4, 5, 6, 1, 7, 8, 9, 10, 11, 12, 13, 14, 15. We now have two groups of 6, remainder 3. So this becomes two groups of 6, remainder 3, all in base 6. 20 in group 6. We also group it in 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this is 1, 2, 3. We have three groups of 6, remainder 2, all in base 6. So let's convert for base 8. We are asked to convert 8 in base 8. 8 is not a digit in base 8, and so we have to convert it to base 8. This becomes 1, 2, 3, 4, 5, 6, 7, 8. Group them in terms of 8, remainder 0. So this is one group of 8, remainder 0. So 8 in base 8 is said to be 10 in base 8, or you call it 1, 0 base 8. 12 can be said to be grouped it in terms of 8 also. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have one group of 8, remainder 4. So we have it as one group of 8, remainder 4, all in base 8. And for 15, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have one group of 8, remainder 7, all in base 8. 20, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have two groups of 8, remainder 4, all in base what? 8. So this is how you can convert from base 10 to any other base using the tally system. You can pause it at this point and look at what I have done to ascertain how I was able to manipulate and get my answers. Let's take more example. Example 2 says we should convert 25 to a number in base 6. Now, I'm not going to be using the tally system because that is just a revision on how they are gotten. Okay? Now, how do I convert 25 5 to a number in base 6 other than drawing. You may be given, for example, to convert 1000 to maybe a digit in base 2. And do we keep drawing your zeros? No. So we are going to be using the long division method. And what does it say? For us to convert 25 to a number in base 6, 25 is given in base 10. So converting it to base 6, what we'll do is we'll keep doing the repeated division. We'll divide 25 repeatedly by 6 to get our values or our digits in base 6. Now, what you will do is you divide 25 by 6, write the multiple plus the remainder. So we'll keep dividing the multiple until we get to 0. So 6 into 25 or 6 into 2, it cannot bring 5, it becomes 25. 6 into 25 will give us 4, remainder 1. For 4 times 6 is 24. So plus 1 is 25. So it's 4 remainder 1. 6 into 4, it cannot because 4 is less than 6. So it's going to give us 0, remainder 4. So in rewriting this, or in getting our values, we pick the remainders beginning from the list from the bottom to the top. So what this means now is that 25 in base 10 is equal to 41 base 6. What this means is that we have 4 groups of 6, remainder 1. And if you look at it, it's the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, these are 4 groups of 6, remainder 1. So this is how you can convert from base 10 to base 6 using the long division method. Example 3, that we are to convert 31 base 10 to base 2. You also use the long division method. Let's solve for A. You divide 31 repeatedly by 2 and write down the remainder. 2 into 3 is 1, remainder 1. This becomes 11. 2 into 11 is 5, remainder 1. So 2 into 31 is 15, remainder 1. Keep dividing. 2 into 1 it cannot. 2 into 15 is 7, remainder 1. And 2 into 7 is 3 times, remainder 1. 2 into 3 is 1, remainder 1. 2 into 1 is 0, remainder 1. So you only stop when you get to 0. Now pick those remainders beginning from the bottom to the top. That gives you the equivalence of 31 in base 2. So 31 base 10 is equal to, we have 5 groups of 1, 1, 2, 3, 4, 5 in base 2. So this is its equivalence in base 2. If you write it down, you still have the same thing. So B, we have to convert 31 in base 10 to base 6. So we are going to divide 31 by 6. 6 into 31 is said to be 5 times, remainder 1. For 5 times 6 is 30 plus remainder 1. So 6 into 5 is 0, remainder 1. Simply because, remainder 5, sorry. Simply because 5 is less than 0. So 31 in base 10 is equivalent to 51 base 6. C, we are to convert 31 in base 10 to base 8. So we are going to divide 31 repeatedly by 8. 8 into 31, this will go 3 times, remainder 7. 8 into 3 is 0, remainder 3. So this gives us 31 in base 10 is equal to 37 in base 8. That brings us to the end of today's class. In today's class, I have shown you how to convert numbers from base 10 to other bases, be it in base 2, base 3, base 5, base 8, base 6, or whatever. Okay, so in our next class, we shall be looking at how to convert from other bases to base 10, which is the reverse process of what we just did now. But before we go, let me give you this as an assignment. You have to convert the following numbers to the given bases. You have to convert A, 117 base 10 to base 6. B says you should convert 89 base 10 to base 6. C, you have to convert 175 base 10 to base 8. D, you have to convert 51 base 10 to base 2. Kindly like our videos as you watch, while we recommend that you subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. We also recommend that you use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the links with your friends and families so that they can also benefit from this class. You can also follow us on all our social media platforms, that is Facebook, TikTok, Instagram, all at My Lesson Teacher Maths. Thank you and do have a nice day. For more content on mathematics like this, follow me for more.